Hi, welcome back. I want to ask you a question that I've asked many students over the years. If I gave you this system of equations, 3x plus 2y equals 12 and 6x plus 4y equals 24, and I asked you the question, how many solutions does the system of equations have? What would you do? Most students I've asked that question reach immediately for a pencil. They start solving. Substitution or elimination. They're working hard within seconds. And that instinct to solve is completely understandable. It's what years of math classes have trained them to do. But here's what I want you to consider. What if the answer to that question required no solving at all? What if you could look at those two equations, just look at them for a few seconds and know the answer immediately with complete confidence? That's not a trick, that's not a shortcut. That is what genuine algebraic understanding looks like. And that is exactly what this video is about. Today, we are going into one of the most important and most heavily tested topics in SAT Algebra, systems of equations. The SAT tests systems of equations at every difficulty level. Easy questions, medium questions, hard questions. And it tests them in ways that are specifically designed to separate students who have only learned the mechanical method of solving from students who truly understand what a system of equations means. By the end of this video, you will understand all three possible outcomes for any system of linear equations, and you will be able to identify each one quickly, confidently, and without unnecessary computation. That understanding is the foundation that separates good algebra scores from great ones. Let's build it. Before we get into the example, I want to make sure we have the right mental picture of what a system of equations actually is. A system of two linear equations in two variables represents two straight lines in the coordinate plane. That's it, two lines. And when we ask, how many solutions does this system have? What we are really asking is, how many points do these two lines have in common? Two straight lines in a plane can relate to each other in exactly three ways. One, they can intersect at exactly one point. In that case, the system has exactly one solution, the coordinates of that point of intersection. Two, they can be parallel, running alongside each other and never meeting. In that case, the system has no solution. There is no point that lies on both lines simultaneously. Or, and this is the case that surprises many students, they can be the same line. One equation is simply a different way of writing the other. In that case, every point on the line is a solution, and the system has infinitely many solutions. So let me put this down on the board. Now, the SAT tests all three of these scenarios regularly, and the mechanical student, the one who only knows how to solve by substitution or elimination, handles the third case reasonably well. But the first and second cases stop her cold, because when she solves mechanically and arrives at something that looks like 24 equals 15 or 0 equals 0, she doesn't know what that means. She's lost. The student who understands the geometry is never lost because she can see what's happening. Let me show you exactly what I mean. Here is our first example, exactly as I posed it at the beginning of this video. 3x plus 2y equals 12, 6x plus 4y equals 24, and the question was, how many solutions? Now, before you reach for a pencil, I want you to just look at these two equations for a moment. Do you notice anything? Look carefully at the second equation. 6x plus 4y equals 24. Now look at the first equation. 3x plus 2y equals 12. What happens if you multiply every term in the first equation by 2? 2 times 3x is 6x, 2 times 2y is 4y, and 2 times 12 equals 24, which is exactly the second equation. These two equations are not describing two different lines, they are describing the same line written in two different ways. And if they are the same line, every single point on that line satisfies both equations. There are infinitely many such points, so the answer is infinitely many solutions. Infinitely many solutions. Now let me show you what the mechanical student encounters. She multiplies the first equation by 2 and subtracts from the second, and she gets 0 equals 0. And she stares at that. What does 0 equals 0 mean? Is that right? Did she make an error? The reasoning student never reaches that point of confusion. She saw the answer before she picked up a pencil. Here is what the SAT was actually testing in that question. Not whether you could execute the elimination method, but whether you understood the relationship between the two equations well enough to recognize that they actually describe the same line. That is an algebraic insight, and it is entirely learnable. Now, let me give you the second example, and I want you to look at it very carefully before you do anything else. Here it is. 3x plus 2y equals 12. 6x plus 4y equals 15. And the question once again is, how many solutions? Take a moment. Look at the left sides of both equations. The left side of the first equation is 3x plus 2y. The left side of the second equation is 6x plus 4y, which is exactly double of 3x plus 2y. So the left sides are proportional. They have the same ratio. The second is double the first. Now look at the right sides. The right side of the first equation is 12. Double that, and you would expect the right side of the second equation to be 24. But it's 15. The left sides are proportional. The right sides are not. What does that tell you? It tells you that these two lines have exactly the same slope because the left sides have the same ratio, but different intercepts because the right sides don't maintain that ratio. Same slope, different y-intercepts. That is the definition of parallel lines. And parallel lines never intersect. There is no point that lies on both lines simultaneously. So the answer is no solution. I'll put that down. The answer is no solution. And once again, the mechanical student multiplies the first equation by 2, subtracts from the second, and gets 24 equals 15, which is clearly false, but she doesn't know what that means. Is the problem wrong? Did she make an error? She second guesses herself and loses time. The reasoning student sees it immediately. The left sides are proportional, the right sides are not. Parallel lines, no solution. 10 seconds, complete confidence, full marks. Now, let me complete the picture by briefly addressing the third case, the one most students are most comfortable with. When a system of two linear equations has exactly one solution, the two lines have different slopes. They are not parallel. They are not the same line. They intersect at exactly one point, and that point is the solution. This is the case where the mechanical method, substitution or elimination, is your appropriate tool. Because here, you genuinely need to find the specific coordinates of that intersection point, and computation is required. But here is the important lesson. Before you begin solving any system of equations on the SAT, before you pick up your pencil and start computing, take 5 seconds to look at the two equations. Ask yourself, are these the same line? Are these parallel lines? Or are these two genuinely different lines that intersect at one point? If they are the same line or parallel, you have your answer instantly with no computation required. Only if they are genuinely different lines do you need to solve. If yes, one solution. Now, let me step back and tell you what the SAT is doing with these questions. The SAT knows that most students will reach for the mechanical method the moment they see a system of equations. That's the conditioned response. That's what years of mathematical education has trained them to do. So the SAT constructs systems that are specifically designed to make the mathematical system feel confusing or ambiguous. Systems where you could end up with 0 equals 0 or 24 equals 15 and don't know what to do with that. And it offers full marks to the student who looked at the equations first, understood what she was seeing, and answered without any computation at all. That student isn't luckier than you. She isn't more naturally gifted. She simply learned to ask the right question before reaching for her pencil. That is the algebraic foundation that separates good scores from great ones on SAT math. Not faster computation, not more formulas, but the habit of understanding before solving. And once you have that habit, systems of equations stop being a source of anxiety and start becoming a source of easy, confident marks. So let me bring this together. Every system of two linear equations and two variables represents two lines in the coordinate plane. And these two lines can only relate to each other in three ways. They can either intersect at one point, they can be parallel, or they can be the same line. The SAT tests all three scenarios, and the student who understands this geometry, who can look at two equations and immediately see which scenario she's in, will always have an advantage over the student who reaches mechanically for substitution or elimination. The habit to build is simple. Before you solve, look. Understand the relationship between the two equations and let that understanding guide you to the answer. In my next video, I'm going to do something a little different, and I think you're going to find it genuinely thought-provoking. We are going to step away from content and strategy for a moment and talk about something that matters just as much: mindset. Specifically, the 4 habits that I have observed consistently in every student who scores 1500 and above on the SAT. These are not tricks or shortcuts. They are ways of thinking and working that produce results that raw intelligence alone never can. I cannot wait to share them with you. If you haven't already, please subscribe so you don't miss it. And in the comments below, I'd love to know, has systems of equations been a source of difficulty for you on the SAT? Tell me specifically what trips you up. I read every single comment, and your questions often shape the videos I make next. I'm Narain, and I'll see you in the next video.